Hello, my name's Jamel. I am a computer science major.
Hello, my name's Olivia, and I'm also a computer science major.
Hey, my name is Brendan, and I'm aerospace engineering intended.
Hi, I'm Allison, and I'm computer science intent.
Hi, I'm Steven, and I'm mechanical engineering intent.
So now you've seen the finished product, but how did we get to this point? By that I mean, what steps did we take to create the second place arcade game, Tuffy's Tilt?
We use the engineering design cycle.
The first step of the engineering design cycle is to ask. Before getting the wood and the power tools we needed to look at what we even needed to do, we had a lot of free reign with this project, but here are a few constraints and requirements. We had to follow size constraints, 4 power sources, including player skill. We needed to stick to a budget of $40 and, of course, make sure the game is fun to play. Also, we weren't allowed to use projectiles or anything unsafe, but luckily, we weren't considering that.
The second step of the engineering design process is to imagine. We took our main first steps with this project by pitching a project idea that fit into the constraints we mentioned in the first step.
All the pitches were pretty cool, but everyone agreed that my idea was the coolest, and that we should take our project from there.
And as cool as Steven's idea was, it really did change a lot as the project went on. The engineering design cycle took us in a lot of different directions.
Also with this step, we needed to come up with how to make our project not only functional, but pretty. Olivia came up with great designs and made it come to life later on in the project.
The next step in the cycle is to plan. We had our idea, but we had absolutely no idea how to get it to work. The tilt mechanics seemed difficult, but how could we get the handle to be the thing that makes it all move? How do we implement obstacles? How are we going to do this by Fed Day?
In this step, we had to do some research beyond just the required research component. We watched a few videos of arcade games people made before, and even some showing components of really complex arcade machines. We were able to get some ideas from there, and had a vague idea of how to make it all come together. In this stage, we also had a required 3D model to turn in, which only had few similarities to our final design. We had to turn that in quite early on, and didn't have a huge plan by then.
But we stuck with that design and really went into our next step, which is create. Just knowing we needed to make Tilt work, and then we could figure out everything else after.
That's why we made our cardboard prototype before even starting with wood. Totally not because the craft center filled up and we didn't realize.
It was for the best that we made the cardboard prototype though, because with that we were able to clearly see something necessary for the next step, which is to improve. With our prototype, the tilt mechanic hardly worked because the system that uses elastic to tilt was up way too high next to the board. Because of that, it couldn't really pull the board down like we needed it to. Thanks to us realizing this, when we made our actual project out of wood, the tilt worked pretty well the first try implementing it.
And so we continued the cycle, continuously going back to ask to make sure we weren't forgetting requirements.
And constantly trying to imagine and come up with bigger and better ideas for obstacles as we went.
Plus, planning and improving our design every time something didn't work. Like on the morning of Fed when suddenly marbles were flying out of the board and we needed a last-minute plastic cover for it.
Or when we realized that the night before Fed, that gluing down the pegs wouldn't be enough and that we needed to drill them in place.
Or when the fidget spinner we attached to a fan we took apart kept falling off.
So before we keep listing things, I think you get the idea. Making this project really was a cycle, and we learned a lot in the process.
And enough about how we designed it. Let's give a quick overview of what Tuffy's Tilt ended up being.
So the base of the game is that you need to tilt using the 2 handles on the sides to roll the marble into Tuffy's mouth, avoiding the abacus we call the wolf's den in the back, because it's basically impossible to get it out then. Totally on purpose though.
One of the coolest parts is the fidget spinner we mentioned earlier, which is attached to a fan. You set the marbles on it, and we turn it on to start the game. They fly everywhere on the board, and then it's just another obstacle that makes things really fun.
We have pegs and triangles on the side of the board too, as well as rubber band bumpers at the front.
Not to flatter ourselves, but Tuffy's Tilt was a big success at Fed. We had one guy who kept coming back to play to be his high score, and it was one of my friends. His name is Isaiah.
And some girls liked it so much they actually told us about the review system that we don't exactly think we were supposed to know about.
Even people who told us they didn't think they'd be any good at it had a great time. Tuffy's Tilt's a game for everyone.
And so I'm sure if you're a freshman watching this video, who will also be participating in FED, you probably want to know how to create something as cool as we did.
Of course they do. So We each have some advice about what we think we did well on or what we would do differently next time if we could do it all over again.
For me, my best piece of advice would be to do the Moodle modules to gain access to the ECE Makerspace in Engineering Building 2 on Centennial's campus. That place is heaven sent.
My advice is to make sure everything is working before FED and account for possible failures on the day of.
For me, I would try and get as many extra resources and materials so you have room for error when making.
I say that you should wear comfortable shoes to FED.
My advice is to start your project the earliest that you can.
We all had a lot of fun making the project, especially since we got lucky and ended up in such a great group.
We couldn't have had a better way to end our freshman year in engineering. I mean, we still have finals, but still.
Thanks for watching our video, and we hope you enjoyed learning about Tuffy's Tilt.